5.4.
Did you say 23 or 24?
23, and yeah, 6 and 7. And then I just had a quick question. Well, I guess maybe could you go over the quiz?
Do whatever you like.
Okay.
Who's honors?
Who's honors? I'm honors, I guess.
Oh,
Is it? It's that time again.
It's that time again. No, there's questions.
So, where'd you post the solutions?
Oh, no, thank you. You guys get solutions?
I had to try.
That last problem, the problem? We got it.
Oh, it's
Are you still in it?
this is our second honors project.
I'm not sure anything about it.
The curve, gravel was the first one.
Huh?
The gravel was the only first one.
And there was a DE on the first one too that he wanted us to solve.
I don't think I ever got this.
The first one?
Maybe. I'm not sure.
Well, that's the second one. The first one was the Pablo with the DE.
Oh, there's the deal.
It was like those beefless.
I haven't gotten to that one yet. The Kelvin one?
Yeah, I haven't done it yet. I got to see how I do on this exam to see if I can even do honors. Otherwise, it's just taking up a bunch of time.
Dude, if you do the right thing,
Oh, no, I was gonna tell you actually, really no rush, I have another one at home. My brother bought an Epiphone, it's a hollow body.
Casino? Was it Sheraton or Casino?
No, it's a weird.
Check that. Does it have
Okay.
does it have like a bound
Yeah,
fretboard?
check it.
Or is it kind of like does it have like a fancy fretboard?
No. It's weird shape, but yeah, it's a semi-hollow. The ones you can play are supposedly kind of acoustic.
Yeah.
Yeah.
Somehow I was gonna say, used to have a somehow. Sure. Got stolen. Ouch, did you get one?
Yeah, I got
Yeah.
Holy crap.
Yeah. I've been a somehow.
Yeah.
$200, but.
How'd it get stolen?
I thought we had fun with the gravel.
We're playing at a bar. This is an open bar, so some of us were not.
Yes, I remember
Not
that too.
set to be keeping track of all our equipment, PA system.
And these Sheratons are expensive.
Sheratons are very expensive.
That's my favorite car, my favorite guitar.
Yeah.
Oh, yeah?
But it's completely stripped and rebuilt all the components. The only thing up on it is a guitar.
Yeah, exactly.
Even electronics, even the pickboard is all gips.
Yeah.
Mine's only 300, so.
My guitar got stolen when we loaded
Oh,
the
so
truck.
you're already taking them.
I left it inside.
Oh yeah, I tried the same thing. Any of the takers of the quiz?
Yeah.
Thank you kindly. Well, you guys, so hold on. You guys truly, who does this?
There's two more down here too.
I wouldn't be surprised if it's Jack.
Who's that?
I wouldn't be surprised if it's Jack.
Oh, quite the contrary. We all received an email from Chuck last week saying, "Don't change."
Really?
Section 13 is this? Is 5.4 to me? Brad,
Yeah.
did we get a result?
It was just a really simple question.
Discrete math.
We're done with it.
5.4. Did you go convenient?
Did you send in the stuff to Michael Kane for discrete math?
No, I didn't send him my numbers. I will.
Okay.
Thanks for
Yeah, because I know Chuck did, and I think Professor Pattengale and Professor Wu did.
Oh, you guys, did I lose my best black pen? Shoot. I just picked it up this morning.
Michael Kane.
Michael Caine is the guy who plays Batman Butler on the new Alfred. That's his name.
Is he?
Yeah.
Yeah, it's not
Really?
Michael Caine.
Oh, the actual Michael Caine, the
Yeah.
actor. Yeah. And he plays the same role in every movie.
Yeah.
Like, you need a wise old British guy, you hire Michael Caine.
Some Michael Caine.
So what does the squiggly equals sign mean?
It's the author's symbol for isomorphism.
Okay.
It's a lousy symbol because you're using that symbol for
approximately.
Yeah, is that P4?
P8. For congruency, geometry.
Okay.
Excuse me, I'm so sorry. Now, when he says, consider V to be subspace of pH such that the odd coefficients are 0, I think what he's really meaning is the coefficients of all the terms in which x is being raised to an odd power, not an even power. Right? No, I'm being honest, that's a question. I don't know the answer. I assume it's the answer.
Yeah.
Probably that.
Yeah.
Yeah, that's right.
And I just think you, oh shoot,
Wait.
I didn't read the question. What am I doing?
Odd coefficients are 0.
Oh, find n such that V is isomorphic. So that V is isomorphic to Rn, right?
Mhm.
Yeah, it is Rn. And if you guys think it's an awkward way to ask a question, I'll change the question. It amounts to the following. What dimension is the subspace? That's all he's asking. And I think we should, you and I should just crank out what the subspace looks like. I think when it comes to V, it's going to be simply the collection of all elements of pH such that the odd coefficients are 0. So, do I have a constant term?
This is what's confusing me. The odd coefficients, does that actually mean that the coefficients are odd, or does that
No.
mean that the place of the coefficients
I
is
think
odd?
it means that the power,
Okay.
or the exponent of that power term, is going to be an odd number. That's all I know.
Okay.
You should get
Got
the
it.
same answer anyway if you use the even coefficient, right? If you disagree with the author about where to start at.
No, I think for even to be different.
Really?
Only because I start and end with even power.
Okay.
So I think what the space looks like, everybody check this out. Constant term plus x squared term plus fourth term. You guys get the idea?
Yeah, except your first term would be, well, yeah, because you're leaving out the a sub 1, a sub 3, a sub whatever.
So by the way, what is n?
5.
So n is equal to 5. Oh, by the way, could you create an isomorphism? What would an isomorphism look like? An isomorphism is merely a one-to-one onto transformation from one vector space to another. And I think probably the most natural isomorphism, did he tell me which way to go? No, he didn't. He used that notation there. So I'll just go from, I don't know, how about V? I'm not writing this correctly, sorry. I meant to say, I'll create a linear transformation from the vector space V to R5. Where? So, how do you think I should identify the isomorphism? How do you think I should identify the isomorphism?
Transformation of
See, I hope you say nothing. There's not there's not n isomorphism. There's many. I'm just trying to create one out of thin air. I think the most natural one would be this. Mapping an L and V, like this one right here that I have already listed. Sorry, you guys, I'm not feeling well. Can I be sloppy today, class? In my chair. I think it's going to be nothing more than this. I'm going to be sent over to a 5-tuple, where position by position, I just have these coefficients. Don't take this the wrong way. That's not the only isomorphism I create. I just think it's a very natural one. Would you guys agree? That's all he's looking for, nothing more.
Will we be doing something like that too? Where we create an isomorphism from a very unnatural vector space to R of n and non-honest operations.
Coefficients.
I don't know. It all depends if you think that this is an odd, strange looking vector space.
Maybe not that, but something perhaps less.
Oh, yeah.
No, because then that makes my life miserable. Because now you're saying, if it's so strange looking, then what is a natural one? There might not be a natural one, which means I'm looking at so many different isomorphisms.
But if we can find an isomorphism from a very odd looking vector space to one of our standard vector spaces, is that useful or not?
Hugely useful. Because what it really means is that instead of working in your vector space, give up. Just work on Rn. because you know so much about RNA, whatever results you might want to pull out of that, then you can go back to your vector space Hayes and say, hey, look, I've got it here as well.
That seems like sidestepping the issue, but in the very legitimate.
But that's the whole point, is getting a nice answer, so I can sidestep the issues. So where else we at, you guys? Number 6?
Yeah,
Brad, are you satisfied with that?
yeah, it makes sense. I just was unclear of the notation and the zero or the odd coefficients. But a really quick question before we move on. So for like problems 24 through 27, we're just finding the inverse linear transformation, right?
Well,
No.
okay, but the inverse matrix transformation is going to be the transformation described by the inverse matrix.
Yes, that's exactly what I did there. But I noticed on the homework or the quiz that didn't really work.
That's different, because I made sure in the quiz that was taken, it wasn't just a matrix transformation.
Okay, so I did something different on the quiz, so I think it works better. But why? Can you maybe explain that a bit more? When it would be appropriate to just do an inverse matrix and when it wouldn't?
Well, sure.
Okay.
If ever you got a transformation from Rn to Rm, if you want to consider matrix transformation, go for it. So T evaluated at a V bar is going to look like an A times V bar where? A is an n by n matrix. But notice the quiz, just at a glance, because somebody printed off. My first example went from P4 to M2.
Okay.
Those aren't RNs.
Okay.
You see my point?
Yeah.
What number 6?
So it has to just be 1, 2 in order to work. So it'd have to
Say
be
that
like.
again, I'm sorry.
So it'd have to be like an R2 to R2.
Yeah, or
But
an
if it
R2
was
to
like-
R3,
Any
kind of
or R7 to
Okay.
R3.
Real dimension, right?
Yeah.
Okay. And so if you're taking a matrix and changing it to like a polynomial, then you can't do that.
Do you see I'm stalling answer your question? Technically, you could get around it by going from like P2
Yeah.
to R3,
Okay.
then R3 to R4, then R4 being isomorphic to M2.
Okay.
You can play games like that.
But if you wanted to do it in an
But if I want
easier
to see
way.
I want to see the direct transformation, then
Yeah.
you wouldn't be using it.
Okay. Okay.
So at number 6, I have the following. So we are supposed to find T2 composed with T1, or you can say the product of T2 and T1. Evaluate an arbitrary vector V bar from the vector space big V. Well, technically speaking, we do know how T1's behaving, and we also know how T2's behaving. And in terms of vector spaces, it's like I've got a vector space V here, a vector space V here. I'm being silly, they're all the same vector space. But T1's mapping to here. I misspoke, didn't I? Hold on, I don't know what's mapping where, I gotta look. So T1's the first transformation. T2 is the second transformation. And I'm thinking the composition has been nothing more than this transformation. Just directly from V to V. The first V, the third. Any ideas?
V can be expressed as a linear combination of V1 and V2, right?
Yes.
So you can just rewrite that as, or then you can split that up into,
Split what up in one?
well, I was just gonna try to pull out the V's, the V1 and V2s maybe. I don't,
What gives you the right to pull them out?
because a transformation of sums is the same thing as a sum of the.
Good, because T1 is declared as a linear transformation, and since T1 is a linear transformation, let me, one full swoop, use both linearity properties. Does it give me T2 evaluated it? T1 evaluated V1 bar, hold on, I just made a mistake, forgot my constant. Plus my C2, and I'm getting too sloppy, that's a V1. C2 times T2 evaluated V sub 2 bar, got my parentheses. It's just that we know exactly what's going on with T1, evaluated V1 bar and V2 bar.
Shouldn't be T1.
Yeah,
It should
you
be
guys,
T1 evaluated.
I made another mistake, and it wasn't intentional. I really did make a mistake. This really should be a,
T1.
yeah, it's the inner transformation. So, let me give the alternative names. That gives me T2 evaluated C1 times stuff, plus C2 times stuff. It's just that the stuff happens to be, well, I don't know, how did T1 get how did V1 bar get transformed under the mapping of T1? Here it is. And let's see how V2 bar got transformed under the first transformation, T sub 1. It's here. Do you guys appreciate how lazy I am? I'm just going by, how these are defined in terms of transformations. I'm told what T1 does to V1 bar and V2 bar. Now I gotta confess, I'm gonna have to do this all over again. Because I'm being told something about T2 have added something clean. And this T2 have added something clean. Okay, you guys, do you mind? I'm sorry. My wife's having car problems, and I just want to make sure she's okay. Never mind. Oy, okay, what was I saying? I'm told something about T2 acting on something this clean. Or this clean. Shoot. It's not clean. Darn it. I guess I better dive in and rewrite this so I can see T2 being evaluated clean V, so V1 bar and V2 bar, P sub A, because T2 is a linear transformation. I'm running out of room. Okay, can I move over here? And so I think, help me, what's this?
C1.
No, number 15. Did somebody ask?
Did somebody ask for number 15? We already did that on Saturday, but if you want to do it again.
Okay,
Go
I'll
for
come
it.
back if I have to. I can't do this, you guys. Shoot. Does that now leave me, oh, it's right there. Does that leave me with, is that a C1 T2 evaluated at V1 bar? Minus C1 times T2 evaluated V2 bar. Plus C2 times T2 evaluated V1 bar. Plus 2C2 times T2 evaluated V2 bar. Alright, so maybe 4 more substitutions, you guys. I've got C1 times something, minus C1 times something, plus C2 times something, plus 2C2 times something, and the somethings are going to be T2 evaluated V1 bar, which is 2 times the first plus the second. And my T2 evaluated, the second vector of the face is going to be 3 times the first minus the second. I don't know, you guys, what do you think so far?
Looks fun.
That being the case, actually, how are we going to write our final answer?
Well,
Group the C1s
Yeah, so, well,
Distribute the C1s and C2s and group the vectors together.
See, I would have done that. I think it would look nice if I just group all the V1 bars together. And if I group them all together and factor out the V1 bar, I think what's left over is this. Is that gonna be a 2C1 minus 3C1? And then plus 2C2. Plus 6 C2. All times V1 bar. Plus, I don't know, is that a C1 minus or plus, excuse me, C1? Plus C2 plus, or should I say minus? Or maybe more concisely. What do you think?
Looks
I
good.
think that's gonna be the transformation of an arbitrary vector V bar in the vector space V.
so would you just leave it like that, or would you write it in like set notation?
Quite the contrary. I don't think we need set notation, because look at what the question
Okay.
really is. The
It
question
just
is
wants
really,
transformation.
how do we evaluate V bar?
Okay.
I think I misspoke. How do we evaluate the composition of these two transformations of V bar? I need to show you, the reader, what the output looks like with the transformation of the
Alright.
input V bar.
So I think you answered 7 for me too as well at that point, so we probably don't have to do that.
So does this answer assume that you, like, know and can find C1 and C2?
Yeah.
by your original-
And by the way, no matter what V bar looks like, we can always find C1, C2. They're just the components relative to that basis. Did I erase the basis?
That's up there.
Yeah, that's set up there. And we'll always be able to find a C1, C2. If that is okay, what about 5.5?
What about maybe 31?
31?
Yeah.
I don't know what proposition 5.13 is.
Yeah. It's on the ballot for next November.
Oh, cooperation. Well, you're really jammed.
Is there a proposition 542 or 543?
Isn't that what this is?
I'm just looking. There we go. Yeah, I see it.
Oh, you can't see anything.
It's a random time to do it.
Random.
Is there anything that's really random?
Huh?
Is there anything that's really random?
Nothing's random.
I wasn't talking about this stuff.
Quantum mechanics.
Yeah.
The thumb trick.
Yeah.
This thing.
But if you define random as probabilistic nature.
Okay.
You married somebody with teenage daughters. How long it took me to train them to stop using the word random? Excuse me. So incorrect. So you guys, let's go back to the proposition. Holy cow, can you read that? The light bulb's going out, I'm sorry.
Kind of.
So assumes V and W are finite dimensional vector spaces, where the dimensions are the same. And let's consider a linear transformation from V to W. Then it's going to be one-to-one if and only if it is R2. Not a piece of cake. I think by the rank nobody here.
Did you lose your pen again?
I did.
It's over there on your desk.
I think by the rank nullity theorem, the dimension of the kernel plus the dimension of the range is going to be equal to the dimension of the first vector space. It's just that, I don't know, you guys, it's an if and only if statement, isn't it? I got an idea. Let's just assume it's 1-to-1 first, and we'll go prove that it's onto. And if I assume this linear transformation is 1-to-1, it means the kernel is equal to, well, the set containing 0 of V. But that means its dimension is 0. So I think I have then that the dimension of the range is equal to the dimension of V. Oh, but wait a minute. V and W had a very special relationship. They had the same dimension. And so I think dimension of V happens to be the same as dimension of W.
Which means it's on too. All right.
Just do what I say, don't look what I write, I said W. But if the range is gonna be a subspace of W, and they have the same dimension, that means the range has gotta be all of W. So I think for free, I've got ontoness. Likewise, coming back up to here, if I assume my transformation's onto, it means this thing is nothing more than the dimension of W. But now when I subtract dimension of W from both sides, these two dimensions are the same. I get 0, but that just tells me the dimension of the kernel is going to be 0, which means the kernel itself has to be the singleton set containing the 0 element of the first vector space. Bang! We just proved that the linear transformation is 1-to-1. You see it?
Yeah.
That was a good question.
I have a question about notation.
Yes.
In the book, it puts brackets around the dimension of the kernel, dimension of the range, instead of parentheses.
Does it really?
Yeah, it does that on all of them.
I didn't know.
I don't know why.
Does it, I mean, how much of a difference does that make in what you're trying to say mathematically?
It makes no difference at all to me. I mean, it's just a simple grouping.
Yeah.
Don't take it the wrong way. If I'm going to talk about matrices, then my notations are important.
Right.
But no, I think when we talk about the DIM of anything,
Yeah.
we just want any symbols to group. Braces, brackets, parentheses. Who cares?
So is there anything on this upcoming test that we should be studying that's maybe outside of what we're doing in the book?
Yeah.
Yeah, all of math, aside from all of math,
Aside from the law of cosines.
and the law of cosines. And is it all in class, or is there a take-home portion?
Do you mind if I just take a peek here before I answer the question?
Okay,
Just so I'm being honest.
there is quite a bit that's covered.
So, this exam starts in section 4-6.
Goes to 5.
Oh, no, it was 4-5, right?
What's 4-5? Linear dependency. Well, I mean, for all of these.
Gosh, you guys, there's not much on this test, is there? What?
There's like 10 chapters, but there are 10 sections.
It's just so straightforward.
Yeah, I know. They all kind of lump together. But a take-home portion would be very helpful to our grades.
I agree with that.
Yes.
You mean for this Thursday?
Yeah. Or just a portion.
Take them apart.
Help us with our grades so we can complete honors projects and do stuff like that.
What do you think outside your kernel? Jason, I'm sorry to get things done. I was sick yesterday, so. It's just too straightforward, you guys. Just too straightforward. I wouldn't worry about it.
Have you written the test already?
The,
How do you?
yeah.
That's cool. It's a quick topic. It's a twist.
Yeah.
If you ever need to,
Party.
yeah, if you never need to authorize some signatures, like this guy or something.
can you post the exam,
Yeah,
the old one?
last semester's.
Last semester's exam? Can you post last semester's exam?
No, all I need is a beat from the Daniel Wade.
Oh, I know, yeah. Linear transformation. Linear transformation. Give her the linear transformation beat.
What is up with all these chairs?
Beat that we made on your phone.
It's the linear transformation beat.
He had
I'm
this,
interested.
he made this app.
Yeah.
It's like a sample pad
Yeah.
where you can record samples.
Yeah.
And so he had me say something on the phone to record it as a linear transformation.
And then there's like.
So you just sampled
just
linear
repeats it,
transformation?
yeah,
and
just over
recorded
and
it?
over.
Alright.
I have this,
Have you guys done the
You
video
guys-
compilation of Val Guy doing
Give me
Jeepers?
some feedback on how the quiz was. I need to know how much writing you do. Was the quiz just really, really easy? You had to think about it, or was it really, really tough? Give me some thoughts.
I would say.
I thought it was easy, and then
Think about it.
I saw I got some stuff wrong, but then had to correct it. But
Mike, wasn't it everything?
What?
Yeah, I noticed that.
yeah,
It is not thinking, I would say, between hard and medium.
the Cauchy-Schwarz inequality. That's awesome.
Because there was only 2 examples and only one of them actually.
May the Schwartz be with you.
No T.
Yeah.
Oh, you're saying I didn't have that
Schwartz.
example?
Yeah, there was only 2 that talked about finding that inverse transformation.
Yeah.
And only one of those examples actually was related to 2. The other one.
Yeah,
was-
this class, I do not have a tendency to give you a lot of examples at all. I have to confess. Let's talk about the kernel. If you guys are doing pretty decent, then maybe skip this work. The kernel is simply a collection of all elements in the first vector space as P4 that are being sent to the 0 element in the second vector space. But if they're being sent to the 0 element in the second vector space, doesn't that imply that this matrix right here, well, actually, I won't write it. This one right here, doesn't imply as a 0 matrix. But that necessarily implies that P sub naught plus 2P1 is equal to 0. And that P sub naught plus 2P1 is equal to 0. That's the fourth equation. Oh, I forgot the second one. That's P2 plus 3, P3, is equal to 0, as well as P3 minus 2P2. But you guys, when I solve the system, just off the top of our heads, don't we get this? I mean, isn't the only solution the first, the second set of equations just a trivial solution? I think, however, here with this system, this necessarily implies that P sub naught is equal to negative 2 times P sub 1. You tell me if I'm skipping too much work. That tells me that as far as the kernel is concerned, that I'm dealing with a collection of all 2 by 2 matrices, where the first entry is did I misspeak? My goodness. Dealing with all polynomials, this one, where P sub naught is
P sub naught is negative 2P1.
and P1 is, and P2 is,
0.
and P3 is, P4 is,
P4.
such that P1 and P4 range over the reals. Oh, I don't like my notation. Can I change it? Change it to maybe a nice notation using span notation. This is the vector space that's spanned by the second 10 elements of so x minus 2. Very nice. I agree. How many of you got that answer?
I think I did. No, I did. I did.
Pretty close.
It's really close.
I learned.
If P naught, P1, P2, and P3 range over the reals, does that give you complete freedom for this entry?
Yeah.
Yes.
Yeah.
Yeah, what about this one?
No.
No.
See, I think it's completely free. I think so is that one. That one's just kind of replacement of that one.
How are they free if they have to be 0?
Whoa, wait, we're talking about the... Sorry, I thought the question was what's the range? My apologies, I was asking a completely separate question. It's a good one, can we just finish the answer for the range? I think it's P naught, P1, P2, P3 range over the reals. This first entry range is over the reals as well. So does this one, so does this one, so does this one, but it's the same as that one. So if I did ask you for the range, which I certainly should have, I think, and I can spell range. And the range, I think, is this linear transformation. Actually, let's force the issue. Let's put it in spanning notation. Anybody?
Zero, zero,
Oops.
zero, one. That's not right. It's 1, 0, 0, 0.
Thank you. I agree with that.
0. Put it out, 3 together. 1. 0. Zero.
No, nothing. We're done. Now, if you think I made a mistake, let's just count. How many elements are in this basis? 3. Well, the rank nullity theorem says this. Dimension of the kernel, which by the way is 2, plus dimension of the range, which I think is 3, should be equal to the dimension of V, the first vector space, or in this case P4, which is 5. Oh, thank goodness, everything's matching up. Do you guys agree?
Yep.
By the way, I failed to answer the question. Is T 1 to 1?
No.
Clearly not, because we'll take a peek at the kernels, not the singletons in it.
So the kernel will be in terms of your V, if you're going from V to W.
Oh, yeah. The kernel is subspace of the first vector space, while the range is subspace of the second vector space. Always. Oh, I'm so sorry, games.
Could you just say really quickly where those 3 matrices came from? When you find
Yeah, I was sort of like doing this. I'm saying, oh, just call this thing R. But wait, if I do, that's R2. That's R1. I'll call this, what's difference? I'll call it S. This is difference, I'll call it T. And so I think the range is set of all 2 by 2 matrices that form R, S, T, R. But now if I split that into sum of 3 matrices, I think it's R times the first plus S times the second plus T times the third.
I think your second's wrong, then. Yeah, that doesn't make any sense, because it would be 0, 1 at the
It should
top.
be 0,
My
1,
apologies,
Yeah.
I am 100% wrong. Like I said, we've got the degree of freedom, and the freedom over here, not in the first entry, we've already listed that.
Okay.
That's right, my apologies.
Because R is the same. That's why it's.
Yeah, those 2 are the same. I agree. It's just as P2 and P3 separately range over the reals, I still think the atoms along the non-linear diagonal are ranging over the reals as well, independent of each other.
For the kernel, what are we trying to look for, I guess, like how do we tell the difference between when it spans something other than 0 and then
Actually, this is a perfect example where the span was not done. This is a perfect example where the basis of the kernel is not that singleton set. And the way I determined that's the case is I just force all the outputs to be equal to 0 element in the second vector space and ask myself, under what conditions is that going to be a true statement? That's why when I started off the question of finding the kernel, I erased it. But I set this output matrix equal to the 0 matrix. And then I just equated these 4 components to the 0 components of the 0 matrix.
in solving that, would, I guess, could the entries of the matrix be put into, I guess a column where it's like one, like for example, R, S, T, and then R, and then set those equal to 0 and solve it that way, or using?
It would make me nervous doing that only because I'm really trying to find out what P